Hey math friends, let's go ahead and check out our study guide here. This is on rate of change, essentially slope, and then a little bit of equations as well. All right, so we're going to check this out here. Eileen and Isabella are practicing their math flashcards. Eileen practices 44.9 minutes per day. Isabella practices 39.7 minutes per day. So we need to use these inputs to show how much time they practice. So for each one, I'm going to multiply it by that number. So this is one where you are allowed a calculator. Definitely suggest using it here too. 44.9 times 2. So if you want to, try this out and then pause and then check, that would be a good thing to do at this point. All right, so we've got our number of minutes filled in for these tables. Remember with our equations here, since these are proportional, they have 0, 0. Our equation is going to look like this, y equals mx. Now our new thing here is our slope or our rate of change. So Eileen's rate of change is 44.9. So her equation simply is y equals 44.9x. Isabella's uses hers. So y equals 39.7x. All right, so now we have to compare these, right? The higher rate of change is typically going to be higher up on the graph. The lower rate of change will be lower, right? Since they have the same y-intercept at 0, we can conclude that y1 is Eileen's equation. We can also conclude that line 2 is Isabella's equation. Right. Let's check out number 2 together. So number 2 has us comparing some cell phone plans. All right. This is a text-only cell phone plan. Number of texts and total cost of two different companies are shown in the tables and graphs. All right, so here's the tables. Here's a graph for it. Now I want to read the question carefully before I go ahead and solve it. Determine the cost per text for each company. So remember this, cost per text. It's going cost per text. So that clues me in that it's money divided by text. Okay, and this I want to find the slope. All right, so remember our slope is our rate of change. So your m, your slope, is your change in y over change in x. Now in my table, I'm going to find my change by comparing two of the points. This is essentially your y2 minus y1 over x2 minus x1. So let's check out our change. From 3 to 4.4 is plus 1.44. From 25 to 37 is plus 12. So I need to do some work here. 1.44 divided by 12. I get 12 cents per text. Let's do the same for company B. My change here, plus 40 cents. Change here, plus 5. Now you could actually use any 2 points and this will work out. This will be a different number, right? Divided, but when we divide it, it'll be the same. So over here I have 40 cents divided by 5, and that's 8 cents or 0.08. So I see company A charges 12 cents per text. That works. Both companies charge the same. Well, they don't, so C's wrong. Company A charges $5 per text. That's wrong. All right, B is 8 cents per text. It looks like there's an error here. These are actually both correct. They both say the same thing. Does either company charge a fee? So your fee here, we want to look at the y-intercept. This is saying, like, to start with us, you need to have a startup fee or a startup cost. So for this, I'm going to look over here. All right, so look at your y-axis, right? That's over on this side. Here's my y-axis. Okay, wherever they cross is the y-intercept. So this one crosses at 0. This is 0, 0. This one crosses at 4. This is 0, 4. So they both do touch the y-axis, but we would argue that a cost of 0 means nothing. So really, company B has the initial fee. All right, now we got to match the equations. So remember, company A has the slope of 12 cents. So really for company A, I have two choices. I only have those first two as choices. So it's got to be one of these two. This is what I'm thinking. Now my graph shows me company A is right here. They start at 0, so this plus 4 doesn't make sense for them. This is like a plus 0. So this is the one that works for them. Y equals 0.12x. Okay, company B, remember they have 8 cents per message. So this 5x is right out. It's one of these two. Now the question is, this 4, where is it? It's a positive 4. They're charging us $4 extra. So I want to use this one, not this one. Y equals 0.08x plus 4. There's a couple other questions about this. Are the relationships proportional? Now we might need to remember what proportional means here. And just to help us recall that, proportional is going to mean that the graph does two things. It passes through the origin, which is that point 0, 0. Also, it's linear, which means that it's a straight line. Remember, in math, we typically don't say straight line because line implies that it is straight. Okay, so company A, let's check them out again. Nope, wrong one. So these are both linear. Okay, only company A goes through the origin though. So this one is proportional, this one is not. Again, they're both straight lines. Company A goes through 0, 0, the origin. That's what we're looking for proportional. So this one is proportional. This one is not proportional. All right, the last part of number 2 here has us having another company that goes $8 for 100 texts. So is that rate the same as A or B? So we have to find this rate. So remember, we do money divided by number of texts. So for this one, let's make the substitution. It's $8 for 100 texts. If I have the words there, it's going to help me. 8 divided by 100, it's 0.08. So that's the same as company B. All right, let's check out the banana tree growth here. It says determine the rate of change shown in the graph. Okay, so remember, rate of change, this is your slope, this is your M, is the change in Y over change in X. Okay, so let's pick 2 points. I'd like to pick 2 points that are close and go up and over. How far up does this go? It looks like one space, but be careful. 8 to 12, this is a plus 4. This is 4 over, and to the right, 1. 4 over 1. Now, here's what's tricky here, right? This is a way to write it if I don't have this form. Sometimes you're going to see this digitally where that wasn't available for whatever reason, but we got to know. And also when I look at this line, it's positive. Left to right, it's going up. Restate the rate of change as a unit rate. So we're going to say we have 4 and what's going up? Height. So 4 inches per, what's our 1 represent? The x value? Days. So 4 inches per day. Okay. Complete the statement below to explain what the unit rate means. Circle one choice in bold in each part. Okay, so we have days or inches is being used at a rate of 4 something per something. So we're going to say inches is being used as 4 inches per day. Again, we don't know why that happened like that, but we make that correction. The relationship shown in the graph is proportional. So again, 2 things. Is it linear? Yes, straight line. Does it go through 0, 0? No, it doesn't. So this one is not proportional. False. All right, let's check out number 4. We're going to use slopes to determine if the 2 lines are parallel. So this is where a couple things. Parallel means they don't touch, right? Do not cross. Okay. Now the tricky thing here, though, is what would happen for 2 lines to be parallel? They'd have to go like this. Okay. So as a refresher, if I'm thinking about them on a graph, or they could be like this, what would have to be the same? The slope. So we're looking at y equals mx plus b, and we want to see, are the slopes the same? Okay, so let's look at this one. This one is y equals negative 10 plus x, but the x is written second. We can rearrange it, or we can notice that the slope is over here in front of the x. So let's go ahead and rearrange it. X plus negative 10. So see how I kept x positive and I kept 10 negative. I could have a 1 in front. So the slope of the first equation is 1. This one is y equals mx plus b. So this one is already good. Slope of the second equation is 1/7. Are the 2 lines parallel? So are these the same slope? No. There's no chance that they can be parallel then. All right, number 5, we're going to plot these, and then we're going to do a translation. So the point 1, 1, negative 3. 1, negative 3. 1, 2, 3. This is point A. Negative 3, 2. 1, 2, 3. 1, 2. B. And then we have to go ahead and plot that. So use a straight edge, usually a ruler, protractor, whatever you got. You can use the edge of a book carefully. I'm using an envelope right here, actually, and that's working perfectly fine. All right, so now we're going to translate right 7 units and call them CD, okay? So remember, translate means to slide, all relating to things that we have seen in the past, which is really cool. So for A, I'm going to go to the right. 1, 2, 3, 4, 5, 6, 7. So this is C. And for B, 1, 2, 3, 4, 5, 6, 7. This is D. And then graph a new line through CD. Okay. And if you do this digitally, you'll have a digital tool that can make the line for you, but you have to know how to put the points on. All right. Look at those beautiful lines. Be proud of your work. All right, our next question, we're going to go back to this page. It says, what is the slope of the line AB? Okay, so it looks like it's negative. Remember, if I put a person on here, they go left to right. If the person's going right, they're going down. That's a negative slope. So the slope of this line, I'm going to go down 1, 2, 3, 4, 5. Go over 1, 2, 3, 4. So this is negative 5 over 4. Okay, let's go over here. M equals negative 5 over 4. Now, kind of looks like this might be the same, but we got to check it. So 1, 2, 3, 4, 5. And 1, 2, 3, 4. Negative 5 over 4. All right, slope of line CD. M equals negative 5 over 4. Are they perpendicular, parallel, the same line, or do they intersect? Well, it looks like they're parallel and they have different slopes. So they are parallel. All right. Next one, consider each of the following relationships. In school A, the ratio of students who bus to don't bus is 8 to 3. So I'm going to rewrite this as a fraction. 8 students who bus to 3 students that don't bus. In school B, the relationship between the number of students who don't bus, y, and the number of students who bus, x, is given by the equation y equals 9 over 4x. Okay, so I do 9 over 4 times that to get the number of students that don't bus. Okay. In school C, the number of students who bus and students who don't bus are shown in the table. Bus and don't bus. I'm going to also write this as a fraction. Which school has the greatest rate of change between students who bus and students who don't bus? Okay, so this is important. Bus and students who don't bus. So we've been writing them in the correct order. All right, so now each of these, they don't have the same denominator, so they're tough to compare. So we'll go ahead and divide. 8 divided by 3. And we're going to round if we need to round. So this is 2.6 repeating. Okay, 9 divided by 4. 2.25. Last one, divide these. 1,313 divided by 146. 8.99315. All right, so which of these is the greatest? 2.6, 2.25, or 8.99? So, yeah, this one's the highest one. So we can say school C has the highest rate of change between those who bus and who don't. Okay. Now remember when it says to explain your reasoning, we can write in words or we can show our work too. So I can say we did and then show our work here. And okay, and we can say so school C was the highest value. Something to that effect. That was 6. Let's check out number 7 here. Some of these are just very long to do, and there's these big graphs on them. So look at this one carefully. It says to create right triangles here. So A and B, and then another right triangle using C and D. So I'm going to go from A down to B, and then over. So this goes down 9. This goes over 6. Instead of do another one from C to D. Ooh, I like this. So down 3 over 2. says the vertical distance for the right triangle connecting point A and B is, so the distance here is 9. I'm going to put a -9 because it's a negative slope, left to right going down. Okay, horizontal distance is 6. Our rate of change, we can write it as -9/6. Now, we can simplify that. Either way is acceptable for this one, but let's do just a little bit of extra work. 3 divides into both of them, so -3/2. Okay, for CD, vertical -3, horizontal 2. So -3, horizontal 2. And we're answering the same question. So I got -3/2. The slope of the line. The thing that's cool is the rate of change and slope, those are interchangeable terms. So if we already know this, we know this. All right, write an equation for the line. So this is a little bit of work here, right? mx plus b. So I've got y equals m, we have the slope, -3/2x. Now b, let's look on our graph. Where does this line cross the y-axis, right? It's either here or here. I have to remember the y-axis is over here. So this is 0, 6. So I want to use the 6, that's my b, plus 6. All right, last one, we've got 3 equations. 1, 2, 3. And we're going to get a value for each of those, get 3 values for each, and then plot it looks like. All right, so first one here, I'm going to use -2 in for x. So negative, and then I put in the value for x, -2. Opposite of -2, 2. Do the same for 0. Do the same for 2. Opposite of 2 is -2. Okay. Let's do the same for line A. So I have -3/2 times x. X is -2 here. Now here's a trick. This is dividing 2, and this is multiplying 2. So those are inverses, but I still have a negative. So this is like a -1. -3 times -1 is +3. Same thing here. Multiply by 0, we get 0. Same thing here. Divide 2, multiply by 2, that's 1. -3 times 1 is -3. Last one. -3/2. So it's really the same as this. And then I have the +1 at the end. I already know that this is 3. And then I have to do a +1. So it's kind of nice when it's similar. 0 + 1, 1. Last one. If I've already done the work over here, I have it halfway done, right? This is -3 + 1, which is -2. All right, I think we have to plot these now. Yeah, graph each line from the table above. All right. So we're going to use the points to help us here. The first point here that we're going to get, and it's just going to help us out, is here's my x value over here. Here's my y value. Okay, so I've got -2, 2. Then I've got 0, 0. I'm going to keep pointing at these so that we see them. Then I've got 2, -2. All right, next one, line A. This is the y values for A. So we've got -2, 3. 0, 0, and 2, -3. Last one here, I've got -2, 4. I've got 0, 1, and I've got 2, -2. All right, when we plot these, we're going to use those points. So I'm going to put this paper on the side for me. -2, 2. So -2, 2, 0, 0. I'm going to show you this too. So these three are going to be together, make a line. All right, 2, -2, then that will make our first line. Draw your line all the way through the graph. Okay. And we can label that. I usually like to label it on the bottom here. Y equals negative x. Okay. So see how this is our first line. These three are going to be our next line. Negative 2, 3. 0, 0, and 2, negative 3. See how that's really close. But again, those 3 points are just a slightly different line for this then. Okay, and then I can say y equals negative 3 over 2x. Okay, so again, these 3 points, let's show these 3 made this line. Now let's do our last line. Our last line is our last 3 points, and then we'll draw a line through. Negative 2, 4, 0, 1, and 2, negative 2. 1, 2, 1, 2. So it shares a point with that. Okay. Now it looks like these last two are like really skinny and they're parallel, and that makes sense because they have the same slope. So this one right here, okay, this is y equals negative 3 halves x plus 1. If you kind of run out of room with how to write these, draw an arrow or even write it on the line. So another way I could do this is I could write y equals negative x here, and then I could go y equals negative 3 halves x plus 1. And then my last one I could write below this last line because I only have 3 lines. I could also write it like that. All right, so we've got 3 lines on the same graph. Looks a little crazy, but what you saw is if I do them one at a time, these 3 points, draw a line. These 3 points, draw a line. These 3 points, draw a line. One at a time, you're going to be all right. All right, so remember, pause, rewind, review, whatever you need to do. All right, you got this.